Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick until the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have x to the power 4 minus 9 is equal to 0. Now, x to the power 4, well, 4 here, this is the same thing as 2 times 2. So if I replace 4 with 2 times 2, I get x to the power of 2 times 2 minus 9 is equal to 0. Now, if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So x to the power of 2 times 2, I can rewrite as x to the power of 2 to the power of 2. And 9 I can rewrite as 3 squared. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a would be x squared and b would be 3. So now I have x squared plus 3 times x squared minus 3 is equal to 0. So now this actually gives me 2 equations. I have x squared plus 3 is equal to 0, and I also have x squared minus 3 is equal to 0. So let's first start with x squared minus 3 is equal to 0. So to solve this, I'm going to be adding 3 on both sides. So then these two cancel out, and now I have x squared is equal to 3. Now I want to get rid of this square, so I'm going to take the square root on both sides. So then these two cancel out, and I'm left with x is equal to the square root of 3. And this is actually plus or minus the square root of 3 because it can either be positive or negative. So this is 2 solutions of x. Now I'm actually going to have 2 more from this equation. So I have x squared plus 3 equals 0. So I'm going to first start by subtracting 3 on both sides. So I get x squared is equal to negative 3. Now I'm going to take the square root on both sides. So then these two cancel out, and I'm left with x is equal to positive and negative square root of negative 3. Well, the square root of negative 3, this can actually be simplified. The square root of negative 3, this is the same thing as the square root of 3 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1, this is actually equal to the imaginary number I. So if I replace the square root of negative 1 with I get x is equal to positive negative square root of 3 times I. So I have x plus or minus the square root of 3i. So these are actually 2 more solutions to this problem. So to put it all together, my 4 solutions are x1, this is going to be positive square root of 3, x of 2, this is going to be negative square root of 3 because it's positive and negative. And now x of 3, this is equal to positive square root of 3i. And finally, x of 4, this is going to be negative square root of 3i. So these are my 4 solutions to this equation. Alright, so I have x to the power of x is equal to 5 to the power of x plus 25. Now, to solve this equation, I'm going to first use an important property of exponents, which states that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, 5 to the power of x plus 25 is going to equal 5 to the power of x times 5 to the power of 25. Now I can divide both sides by 5 to the power of x. So then these two cancel out, and I'm left with x to the power of x over 5 to the power of x is equal to 5 to the power of 25. Now, if I have something in the form a to the power of m over b to the power of m. This is equal to a over b to the power of m. So x to the power of x over 5 to the power of x, this can equal x over 5 to the power of x. Now this is equal to 5 to the power of 25. Now I'm going to take the power of 1 over 25 on both sides. So now I have x over 5 to the power of x to the power of 1 over 25 is equal to 5 to the power of 25 to the power of 1 over 25. Or sorry, I'm going to be taking the power of 1 over 5, not 1 over 25, which is equal to 5 to the power of 25 to the power of 1 over 25. Sorry, again, 5. So now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So x over 5 to the power of x to the power of 1 over 5, that's going to equal x over 5 to the power of x times 1 over 5. Now this is equal to 5 to the power of 25 times 1 over 5. Now x times 1 over 5, that's going to simply equal x over 5. And 25 times 1 over 5 is the same thing as 25 divided by 5, which is simply 5. So now, if I have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b. So in this case, x over 5 to the power of x over 5 is equal to 5 to the power of 5. This means that x over 5 is equal to 5. Now, to solve this equation, all I have to do is multiply by 5 on both sides, so then these two cancel out, and I have x is equal to 5 times 5, which is 25. So now to check, my original equation was x to the power of x is equal to 5 to the power of x plus 25. So now we know that x is equal to 25, so now if I substitute in 25 for x, I get 25 to the power of 25 is equal to 5 to the power of 25 plus 25. Now 25 plus 25 is 50, so I have 25 to the power of 25 is equal to 5 to the power of 50. Now, instead of calculating these two exact values, I'm actually going to simplify these and make them the same exponents. So 25, this is the same thing as 5 squared. So now if I replace 25 with 5 squared, I get 5 squared to the power of 25 is equal to 5 to the power of 50. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. So 5 to the power of 2 to the power of 25, that's going to equal 5 to the power of 2 times 25, which is equal to 5 to the power of 50. And 2 times 25 is 50. So I have 5 to the power of 50 is equal to 5 to the power of 50. And because this is right, our solution is right as well. Alright, so in this video, I'm going to be solving the equation x minus 4 to the power of 4 is equal to x to the power of 4. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution, what I'm first going to do is rewrite this equation as x minus 4 to the power of 2 times 2 is equal to x to the power of 2 times 2. And the reason I did this is because now I can use the property a to the power of m to the power of n is equal to a to the power of m times n. So using this property, I can rewrite x minus 4 to the power of 2 times 2 as x minus 4 to the power of 2 to the power of 2, and I can rewrite x to the power of 2 times 2 as x to the power of 2 to the power of 2. Now from here, this is going to turn into x minus 4 to the power of 2 to the power of 2 minus x to the power of 2 to the power of 2 is equal to 0, because I just subtracted x to the power of 2 to the power of 2 on both sides. And now I can use the property a squared minus b squared is equal to a plus b times a minus b. So in this case, a is x minus 4 squared and b is x squared. So this turns into x minus 4 squared plus x squared times x minus 4 squared minus x squared is equal to 0. Now from here, I'm going to expand x minus 4 squared. So x minus 4 squared is equal to x squared minus 8x plus 16. So over here, I get x squared minus 8x plus 16 plus x squared times x squared minus 8x plus 16 minus x squared is equal to 0. Now x squared plus x squared is 2x squared. So I get 2x squared minus 8x plus 16 times, these two cancel out, negative 8x plus 16 is equal to 0. And now I get two equations. 2x squared minus 8x plus 16 is equal to 0, and negative 8x plus 16 is equal to 0. Now from here, I'm going to factor out 2, so I get 2 times x squared minus 4x plus 8 is equal to 0. And from here, for this equation, I have 8x is equal to 16. So if I divide both sides by 2, I get x equals 2. That's one solution. And now continuing this, if I divide both sides by 2, I get x squared minus 4x plus 8 is equal to 0. And if I use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. In this case, a is 1, b is negative 4, and c is 8. So I have x is equal to negative of negative 4 plus or minus the square root of b squared, so negative 4 squared, which is 16, minus 4 times a, which is 1, times c, which is 8, all over 2a, so 2 times 1. And this turns into 4 plus or minus the square root of 16 minus 32 over 2, which turns into 4 plus or minus the square root of negative 16 over 2. So now, the square root of negative 16, I can rewrite that as the square root of 16 times the square root of negative 1 over 2, and the square root of negative 1 is equal to I. So I get x is equal to 4 plus or minus the square root of 16i over 2, and the square root of 16 is equal to 4, so I get x is equal to 4 plus or minus 4i over 2, which turns into 2 plus or minus 2i. So my three solutions of x are x is equal to 2 plus 2i, x is equal to 2 minus 2i, and x is equal to 2.